This is AQA GCSE Chemistry. It is the 2018 Trilogy 1H higher paper. And this is question 8. The whole of the question is going to be shown at the beginning for you to pause and try, and then you can review in the remainder of the video. So here is part 8.1 and 8.2, 8.3, and finally 8.4. There are 10 marks available in total on this question. So if we go back to the beginning, a question about iron. Iron reacts with dilute hydrochloric acid to produce iron chloride solution and one other product. So you have got to remember that a metal and an acid will make a salt and hydrogen. It's one of the general equations that you simply have got to know. Suggest how any unreacted iron could be separated from the mixture. Well, this is essentially asking how you can remove any solid impurity, and you do that using filtering or filtration. On to 8.3, we've got a big calculation here. 0.12 grams of magnesium reacts with excess iron chloride solution. Calculate the mass of iron produced. So we have got here a table where we've got the species we know the mass of, the species we want to know the mass of, and then we build in our mole calculation. Mass, molecular mass, moles, and ratio. You can see that I was told 0.12 grams of magnesium, so I've put that in, and I can go to my periodic table, or I can look in the question here to see magnesium has an atomic mass actually of 24. Now, if I've got my M and my MR, or M and AR, I can do M divided by MR to get number of moles, which is 0.005. I next need my mole ratio. Now, I've got to go back earlier in the question to do this, and I've put the equation down here. You can see that 3 moles of magnesium make 2 moles of iron. So my mole ratio is 3 to 2. And if that's the case, if 3 moles make 2 moles, following that ratio, 0.005 moles make 0.033 moles. And I've got that, and I've got my atomic mass of iron that I can put into my table. Because I've got these two, I can multiply them together, and that will give me a mass. It comes to 0.187 grams. However, the question asks for the answer in milligrams. So I've got to multiply that by 1,000. The correct answer, 187 milligrams. On to 8.4, explain which species is reduced in the reaction between magnesium and iron chloride. Include the half equation for the reduction. Well, I'm going to take the opportunity to do a full ionic equation here and then break it down. Because if I go through, I'm going to break up anything that's ionic and aqueous. We've got no state symbols here, but ionic compounds here, the salts will be aqueous. So I break those down. My Mg and my Fe stay the same, but once I've got my 2Fe3 plus and my 6Cl minus, my 3Mg2 plus and my 6Cl minus, I can start to identify spectators. I've got 6Cl minus on both sides of the equation, so I'm going to disregard it. From there, I can start to build my half equations. My 3Mg goes to 3Mg plus 2. To do that, I'm going to need 6 electrons on the right-hand side. Because the electrons are on the right-hand side, that means magnesium has lost 6 electrons to become 3Mg2+. Loss of electrons is oxidation. The question is about reduction. So it's going to be Fe3+, going to Fe, and it's 2 and 2, so I'm including those here. To get from 2Fe plus 3 to 2Fe, I need to gain 6 electrons. Reduction is gain of electrons, so Fe plus 3 has been reduced, and this is the half equation that's credited with a mark. And that takes us to the end of question 8.